Alright, let's go! Welcome back to another week. We are going to hack on a cool game we've been making, or at least I think it's cool. Hopefully you do too. Lambda Trek. Just, if this is your first time tuning in, this is what it looks like. It's a clone of an old game that's had many variants over the years. I think it goes way back to like the 70s, when good old humble nerds were making fun games on really large computers at the time. And one of the first games, one of the early games that they made, it was a game called Star Trek. It's also been, has had many spin-offs and variants like Super Trek and such. And we're building a modern variant of it today in Haskell. So that looks like, so far, this. Here we have our little space view of our current quadrant that we're in. The S is the player's ship. This little arrow over here is an enemy ship. This is a star. And we're going to start adding and filling out more things, but we're in the middle of building things right now. We have a little ship status panel over here on the right that we'll be adding more detail to as we simulate more things over time. Our little command input where we can move our ship around with our little handy dandy move command. We have our little dialog box here. So we're using this idea of having the different characters that are on the bridge giving you information about what's happening in the simulation, so that we're not just like bleeping out and breaking the fourth wall here with our game. But we do that for like parse errors and stuff on the commands still. So that's all cool. Last week we started working on firing phasers. And yeah, so it takes down your energy. It auto-fire, if you just don't specify manual fire, it auto-fires on everybody in the range, all the enemy ships in range. And this week, I think we're going to clean up the code a little bit for that. And maybe start adding some dialogue feedback about the damage we did in there. And figure out what we're going to do with that. So let's continue on the adventure, shall we? All right. Open up my little text editor. And we're going to go into source, Lambda Trek, and we'll go right into the simulation here. So here we have a lot of our game handling code. All right. Handle command is going to take that initial game state and command. It's going to dispatch out to from the different commands to the different functions that handle those things. And that's our engine movement, and then our fire phaser stuff. And this big old function here. And I think one of the things I'm going to work on here is I kind of speculatively cut out a combat module. I think I'm going to bring that back because combat is going to be fairly interesting. It's only going to get more interesting over time. And I think I want to add the combat functions to be like state functions. So they're going to run and they're going to do multiple things with the game state as they do their mojo and work their mojo. So let's bring that idea back. Module Lambda Trek simulation.combat. Okay. So here we're going to bring in handle fire phasers. I'll just copy that over for now. And we're going to need some imports. Some lambda trek.state. And phaser mode, that comes from the ship module, I think, maybe? No, command. Yep. And then some ship stuff. We need array. As array. We also need enemy and record wildcards. Let's get this module set up. Okay, we keep an eye on chat. Make sure you're all rocking and good. By the way, if you ever have any questions, you know, you can always stop me and ask. It's all good. Happy to answer. Figure things out. So let's import Lambda Trek simulation.enemy. Oh, we import those qualified. And qualify for enemy as well. But we also need the type. Enemy. Maybe the constructor. We'll pull them both in. Okay, and we need ship in the same manner. Okay. Good, good. And enemy we need lenses. Lens.micro. And enemy ships. We got that from Sector, I think. Yeah. And second, which comes from data.byfunctor. There we go. I did mean by functor little m. Thank you, GHC. And we're good. Okay. So the first thing I want to do here is turn this into a state function. So we're going to import control.monad.state, I think. The MTL on transformer, which re-exports from the transformers package. This whole idea. And we only really care when executing this, executing it as a state thing, the return value isn't super necessary. So in order to make this work now and start compiling again, we just have to like return our value in this. Oh, right. We have to change. No. Sorry. We're returning pure. We're returning unit. Sorry. And we're changing the game state. So we have to change these to like puts. This can be just pure unit because it doesn't change the game state yet. So we haven't handled manual phaser fire at the moment. But we're just doing automatic. Okay, so now, to get this to work again, we want to put these different game state things in here. So Lens.micro has, I think in the ecosystem, it might have a library for doing this, or maybe it has in the base library. Microlens.mtl. So these add some lenses for working with MTL monads, which are super convenient, and it's probably the second most used set of lenses that I use, beyond just like the ones we've discussed before, which are like viewing, setting, and over. So MTL ones are super neat, especially when you use them with the state function, the state T monad. The state monad, because they do like super cool stuff that will make this code much nicer. So we have a set operator that sets a value in our state, which is super cool. We can assign a value to the state. We're going to use this. I don't think we have it in our package yet, so let's go add that. Package. Yes, yes, micro lens. MTL. This is what we want. And I think we have to import it. Lens.micro.mtl. Not MLT, of course. Not MTK. The MTL is the one we want. Yes. Okay. Now, I think we can get rid of this intermediary binding for these let things. And this will be much, much cooler. Let's put a do there. Get rid of that. Get rid of this. And here we can set what was the operator? Setting dot equals. And then this one here, we are changing the state sector's enemy ships. So we'll set our lens on the left side here. And there's a convenience one to chain lens operations. Okay, I don't know if we need that one exactly, but the game state sector, we are going to we could do that? No. Maybe I can put the whole thing like this. This is me noodling around with lenses. We probably want over that state. Yeah. Okay, cool. So that compiles, and it probably works. Get our builder going here. Fast and file watcher, we'll turn that on so that we can constantly recompile as we go, as you do. course, I need to be in the right directory in order to get that going. There we go. And what do we got here? Oh, right. We need to add MTL, of course. That makes sense, right? Of course it does. And a finger slip. And I minimize my editor. There we go. Okay, there we go. MTL. Of course, we're not using this new function yet. I'm just making sure it compiles. That's good. Oh, we also have a bug we gotta fix. That's nice too. We'll fix that too. Okay, so let's go back over to the simulation. See if we can get rid of fire phasers. Now we need to get the game state back. All right. We're going to import our simulation from our combat module. Lambda trek dot simulation dot combat, and we're going to need a run function for that to run the state, and we're going to get that from control.monad.state. We still need to give our input parameters here to handle fire phasers, but now we're just going to do I think it's exact state, if I remember correctly. Right. There's one more thing we need to get rid of. We can get rid of the game state parameter here and here. And instead, we get the ship from that. We got view. We have a view thing. Blah, 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 blah. Where is it? Monad reader. No. We don't want setting. What's zooming? Super. Zooming is cool. I like that. Does view maybe work just on viewing the monad state? I guess, yeah, I guess we can just dot equals like this, but we can get turn simple to do. We can get rid of the let. The ship becomes a bind. Use game state ship. And then game state here. This can become used. Not quite, no. We'll just get sector as use game state sector. We'll change this to view. Oh, not game sector, just sector, sorry. How's that? There we go. Hey, Diahex. What's going on? Why Emacs? It's just what I've been using for like ever. I was a Vim user many moons ago for a good long time. From about the 90s until 2008 or 2009. And then I switched to Emacs when I was getting into Lisp. I hated it at first, but it grew on me. And now we're here today. Okie dokie. Right, so now we gotta change that. So we don't pass the game state explicitly in anymore. We pass it in with exec state. And it takes the arguments in a weird order. Okay, we don't use record wildcards in here anymore, so let's get rid of that. And bifunctors, redundant in here as well. Super. Okay, so now we've moved that, refactored that out into a state. So now we can have a combat module that, you know, changes multiple parts of the state and is like pretty straightforward to work with, hopefully. I'll make that a little bit easier. So let's just make sure that our changes actually like worked. Let's check the game out, make sure we're up to speed. All right, everything still should be the same. I'll move 10 and 10. That's where the star is in this corner here. So we try to move there. We're going to get a message from our helm saying, Captain, that would take us directly at the star, 1010. Oh. So we can't move there, but let's move 3, 2, 2. We're already at 2, 2. That used a little energy. We should probably fix that. All right. And then we can do phasers. We use like 30 energy, say. All right, that did a bit of damage to the enemy ship. It reduced some of our energy. Everything's working about the same. Looks like. Which is good. Okay, next part. Let's see. Well, we do have that bug with the range function. Let's fix that quickly. Let's see what we can do with that. Okay, so the bug here, well, actually, let's make this bug easier to visualize first, and then we'll fix the bug. So the other thing I wanted to do was add some dialogue from, say, our combat person. I don't know what you would call it, like security operations combat guy, gal, person, alien, who knows. And they're gonna tell us, I think for the design of this game, like, they shouldn't give us an exact number of damage we did, but like kind of a descriptor of that damage. We'll just make it a number for now, just so we can see what's going on, and we'll just use a function to give ourselves an affordance to change that decision later on and do the thing we want to do. Because that's what we do. Use functions to create abstractions. Ooh. Not really, but kind of. Okay, so dialogue. Our dialogue system. Boom, we have to add a new crewmate. Let's call them Combat. Okay. Now, Combat is going to create some unused non-exhaustive case warnings that we have to go fix in the UI for rendering their dialogue. Combat. And we just use raw VTY terminal codes here to color our text for this widget. And we use VTY.red because red, angry. Combat, angry. That should work for that. Next, what do we got to handle? Is that it? Super. Okay, then we need to add some dialogue. What I want to be able to do is add dialogue, combat. We hit the ship. Let's just make that string show up and work first. And then we'll make baby steps here. A little bit of progress at a time. I don't think this exists yet, so we need it. I want to say add dialogue. Let's say dialogue. Okay, so we don't have a function called say dialogue that takes a T0, a string, a list of dialogues, and returns a list of dialogues. Whatever that is. Could be like this. This is the actual function we need to write here. Okay, Haskell is just getting a little confused. We haven't defined this yet, so let's go define it in the dialogue module. Gonna have that type. Actually going to have the crew member, the crewmate, the string that we want them to say, and then that stuff. Let's bring it over to the left a little bit so we can just see it. We'll get rid of that. And that. Wonderful. Okay, so all we have to do is construct the dialogue from these two pieces, append it to this, and that's what we return. So our crewmates, the dialogue. we'll call it say in the dialogue so far. Oh, string, sorry. Text. That's better. Okay. Now, what do we got here? Okay, it's not in scope still. Let's bring it in scope. Wonderful, and we just need overloaded strings for this last type error, which is no biggie. I should just have that enabled everywhere. Okay, and that compiles again, so this should now go, and we say like phasers 90, whatever. Okay, there we go. Combat, hit the ship. We try to move 10-10. Boom, hell. Oh, they'll take us right to this tower. Can't do it. Perfect. Game's shaping up. Ship it. No, we got a lot more to go for this game. So, all right, we can say we hit the ship. Now we want to say, let's just append how much for now. But we're going to use a function to generate that string. Damage dialogue. And what do we need to pass in for us to generate that? We need to pass in how much damage we did. We're going to want to do a bunch of dialogues, because we do hit many ships at once here. Yeah. So we're going to need the enemy position and the enemy ship so that we can know when we read that dialogue who was hit for what. Yeah. Okay, so we have damaged enemies. That takes the enemies in range and applies the damage to them so that we get a tuple of enemy indices into the array and the enemy ships that we updated. The enemy ships have their position information and the damage they have on them. But we don't have the we only have the damage amount in this map. Right now we're using a fixed damage amount, but I eventually want to add a little bit of randomness to that, of course, to kind of tweak things a little bit. So I think what we could do here is return just a little bit more information about the damaged enemies. Or the damage we're going to apply, that we ultimately apply to them. Looks like the enemy ship definition. We could put that data here with the enemy. How much they were hit for. Well, they were last hit for. Or we could make damage enemy return the enemy and the amount that they were hit for. But we already know sort of what that amount is. Yeah. And this is, yeah, another good reason why do you, yeah. So we want to vary we're ultimately going to vary the damage amount. You know what? Let's handle that in another step. I feel like we're walking too far here. Let's just use the damage amount that we have here. This will be our baby step. We just want to get this dialogue line going, and then we can reuse it however we need to. When we want to, like, recalculate damage amounts and map them and stuff, we can create all the dialogues we need from that, as long as we give it the damage amount and the ship location, or the ship. Yeah, we're gonna need the ships too, actually. Burp. Okay, so yeah. Game state dialogue is going to be say dialogue. We're gonna map say dialogue over the damaged enemies. Can write it. I think we can use that groovy ghoul empty on my thing to zoom in on the dialogue. That's neat. Say for in game stage damaged enemies. For each damaged enemy, we're going to say dialogue for that enemy. Okay, generate damage dialogue. That's going to be a damage amount, an enemy ship, and we need to return a text. Damage dialogue. Amount. Enemy. Yeah, we'll use record wildcards here to pull out the enemy fields, and we just need to return a text. Okay. Oh, I don't have that type in scope. Let's bring that in. Data.text. Okay. Oh, I didn't type that right. All right, it's a tuple. We're going to ignore the array index. That, and just use that. And then what do we got here? Did I not use zoom properly? Okay. Yeah, I don't think, maybe we don't need really to zoom. Let's get rid of that. Let's just use 4 for damaged enemies. We can then game state dialogue. Matcha the dialogue just as before. Super duper. Okay, so now we just need to generate the text dialogue. Get damaged enemy. Yep. And we'll put a parenthesis there. We'll put the we're gonna need text import data.text qualified. Just qualified as T. T.show? No, T.pack. Enemy position X. Not pause X, it's position Y. Or it's just not in scope. Yeah, oh, it's full on position, yeah. Okay, that's why. That should be unpack. Yeah, what do we got here? Match text with string to text. Okay. What am I doing here? Let's put a hole there and just ask JC to tell us what it needs to be here. Okay, int to text. Yeah, so let's do show. Apply show combined with something else. T.pack. That's the one I wanted. Wonderful. Okay, continuing on. Should probably make a helper function for that. Enemy position Y. We'll put a close parentheses. 4. And then we'll have amount. There we go. Wunderbar. The other part, the bug, is if we move to 1414 and we try to fire phasers here, it still hits it. We want that to be out of range. The idea is that we had like a box, we have a box around the ship of a certain range, and we can't use phaser fire outside of that range. So let's fix that. That's the enemy in range bit here. Actually, let's take a pause and work on some commits here. I probably should have broke this up into smaller bits. Okay, let's add those. Add a say dialog. Also added the combat crewman version. Boom. Yeah. And then this will go refactor, handle phaser fire to combat module. We now use state to transformer to handle complex combat logic. Boom. Okay, getting back to it. Bug. So, top left, top X, top left X, top left Y, offset X, offset Y. The int and enemy, the enemy index, and the enemy itself. Which we ignore the index, we just want enemy thing. We use enemy in range for a filter function up here, calculating the range box corner and the range box offset for those two tuples. The range box corner is a minimum of 0, or the ship's current position minus its phaser range. So, when we start up in our default thing here, or if we move to 1414, our phaser range, I think, is 6 initially. Ship? No, it's in the state. Initialize the ship. Yeah, default range of 6. So that means at 14, our X position minus our phaser range would be 8. Right? So that's the top left of our corner is 8. And our top left Y should be our shift position, which is 14, let's say. Minus 6, which is 8. So it should be 8, 8. Right. And the enemy ship that we initialize with the initial sector Ooh. Oops. I duplicated logic here. I already have an add dialogue function. Oh, I'll get rid of it. Anyways, It's a sector, maybe? Yeah, so our initial enemy is at 8-3. Okay. And then our range box offset is a maximum of 15. I think that should be 14. And it's the ship position X plus the phasor range. So at if we're at position 14, that means that this is the maximum of this would be 14. Because this would be 20. And same with this. So we should have 8, 8, 14, 14 when we go into enemy in range. 8, 8, 14, 14. Okay. So if the enemy position X is greater than or equal to top left X. So the enemy position X is 8. That's true. Okay, and the top left X plus the offset X. So it's 8 plus 14 is greater than or equal to enemy position X. That's also true. I think that's the bug right there. Well, no, that could be fine. Yeah, top left X plus offset X, right? So 8 plus 14. I mean, yeah, both of those things are true. And the enemy position Y is greater than or equal to our top left Y, which is 8. The enemy position Y should be 3. That should be false. So this whole thing should be false, which means this filter should drop that enemy if we're at 14, 14. Let's add a little debug tracing. I think I might have an idea. This is just a matter of getting the right relations set up. But let's just make sure. So let's debug. Boom. And we're going to pop that puppy over here. The enemies in range is what I want to see. We show enemies in range. And the better way of doing this would probably be to start setting up some tests, because we can unit test this stuff. I'm doing it the hard way. Phasers. Yeah, no bueno. Okay. So So let's break this out and create a test for this, because this will be a lot faster than trying to do it this way. And then it'll make our code better in the long run. Let's get rid of debug tracing. Okay, so test code lives over here. Spec. Describe Lambda trek. .simulation.combat. We're going to talk about enemies in range. When the player ship is in phaser range. No. Let's just use an if block. It should return only the enemies within the specified box range. And that's all it should do. When there are no... Let's start with the simplest case. When there are no enemies. It's trivial, but it's useful sometimes to just do things this way. So enemies in range. Let's bring that up. Let's break this function out. Enemy in range. And we don't need this empty we don't need this empty case. Describe enemy in range. Should return true if the enemy is in range. So if I give it a box of 0, 0, let's do a very simple box. Say no bigger than 3, 3. And the enemy, let's construct an enemy. A test enemy. This, and we'll make the enemy's position X1, 1, 1. Gotta bring a lot of stuff in scope. And we're gonna bring combat into scope as well. And we're going to make this a function. going to just make that not a tuple. And just refactor this a little bit. Oh, yeah. Data.function. I think you might have some. Yo, ISO Vector, what's up? Thanks for tuning in. It was nice to see you, as always. Sorry it took me a second there to get to you. I was just deep in thought. We're making a new game. It's a clone of a really old game. It's called, I'm calling it Lambda Trek. It's basically this old strategy game that dates all the way back to the 70s and has like hundreds of clones and variants called Star Trek or Super Trek. We're calling this one Lambda Trek. The idea is you give your commands to your crew. And they tell you stuff that happens. The goal of the game is to destroy an invading fleet of enemy ships within a certain time limit using the available resources to you. And if you're successful, congratulations, you win. If you run out of energy or you get destroyed, you lose. And that's pretty much it. So we're exploring designing and building a game using Brick and a TUI for it. Maybe one day we'll add a graphical layer to it, but that's it for now. Just some fun times. So yes, I'm going to fix up my code here. Okay, so this filter function, and now enemies in range is technically keeping the indices and the enemy ship so that we can do the array update on the sector. The filter, though, is only the enemy in range function is only concerned with the enemy, not necessarily the first part, but we just want to return the bool. This isn't composing with second, because that's not the right function. That might be the right one. SND. The second of the tuple. There we go. Okay. So now we've factored enemy in range out. We can start writing our tests for it and getting our test runner running on it. Combat imported. Is there an example? Enemy should be true. Yeah. Enemy in range. Yeah, that should be there. So let's get our tests going. Not make, but stack. Fast with our file watcher. Get rid of this bug. Okay, let's see. Oh, I haven't updated the tests in a while. That's right, we added some new stuff to ship, didn't we? Stuff that doesn't matter for that test, we'll just fill in 0, 0 there. Yeah, oh, broke another test. Different one. Because again, I haven't been running these regularly like we probably should. Okay, well, that's expected state, sorry. Should probably have initial state. Ship energy 106. This one to be 2-2. I'm getting some dialogue for me to do that. I'm probably adding the wrong thing, aren't I? Do. That shouldn't matter for that test. Right, our initial state. That's why it's failing. This should be like, maybe like 8, 10. That's why it's doing that. I'm a derm. Been a while. Okay. So that one should fail. And it moves to the empty space 10. 98. Okay. Okay, so that is returning true like we want it to, but the bug is that if it's out of range, it's still returning true, which should return false here, because enemy should be out of range. Return true. So we specify 0, 0 and 3. No, let's say like 8, 8 and 10, 18, 18, or even 8, 8. Example enemy. Should be false. I think it'll return. This little test will fail, and it'll return true. Oh no. That is not what I expected. Okay. That function should be fine then. Where's the problem? It could be in the is it in the calculation of our range box offset? I don't think so. Although it could be the Well, actually, yeah, we don't have to calculate the offset as the absolute position on the map here. This should just be the ship phaser range. We don't need the max on it. We could pull out more of this, and add some tests for that. Describe enemies in range. Let's get some example enemies going. Let's see. Enemy at 111. Enemy at 121. And good return. Let's make this one a little further off. 441. All enemies in the range. So we do enemies in range, and we do this kind of like the similar API we had for the other function with enemy in range. We give the top left corner and an offset tuple. So we start at 0, 0, and we give an offset of 8, 8. That should compass everybody. And some example enemies. And that should just be example enemies. And one more should be some enemies in range. Yeah, that's a good enough spec, I think. So if we have enemies in range 0, 0, but our offset is only 2. So from our example enemies, we should get just the one. Enemy 111. If we had such a function. So let's make enemies in range such a function. Int, and a list of enemy. Return a list of enemy. Nothing super fancy. Just breaking things down a little bit step by step. Okay. And offset X and offset Y. Enemies. And then what do we do? Bow, bow, bow. use 0.3 if we want to. We're filtering on some function. Although, in this function we have the array of socks because we want to keep the indices for the update. Yeah. We could just change our function to do that. Make this an array instead of list. And this will return the tuple, the association list. We're going to need this to be an array. Let's get this filter going, huh? So the first thing we're going to do with array.enemies is we're just basically take that function we have up there. That's what we're going to do. Get rid of that. We'll call it enemies. There's one more. Offset and vector enemy ships. Okay. Bring that there. Pop, pop. Don't like that equal sign hanging off the end there. How? Oh, okay, yeah, we'll pull that apart. We'll just call that range box corner. Range box offset. Okay, so our test. We're going to need to import data.array. And I believe array has from list. And this will be something like that. Okay, and I gotta add it to the test package, of course. it's not from list. What is it? Oh, just array or list array. You do list array. And that'll be 0 to 1. Enemy. I'll make this a little easier on this. Enemy list. Yeah. Yeah, let's do it this way. Pop this over here. Zero enemy 111. Colon thaw. And 1. Enemy 441. Okay. Okay, this isn't cutting it. What's going on? Phasers. 12. Ooh, that's no good. Divide by 0. How did we get that? Ooh, scary. Okay. So in the process here, we've broken something else entirely. Super good stuff. Okay, that's the length of enemies. If we are out of range and there are no enemies found, then dividing by 0 would give us a divide by 0 error. So phaser automatic. We can do absolutely nothing if there are no enemies in range. And that would be true of phaser automatic and phaser manual as well. All right, we can guard this. We can say length of enemies greater than 0. And just pop this over here. Let's see. Oops. What do I do? No, don't set the mark. What do you do? There we go. Oh, is there no Mona plus instance for this? There isn't. Okay. Let's try when. not null enemies is better. Okay. Okay. Okay, that's good. Let's run our game again. So if we move 1414, wave phasers. Okay, cool. We fixed the bug. So there you go. Super. But if we move closer to the ship, we should get it back. We should still be able to shoot from here, say. Ah. But we are no longer able to actually hit the ship now. Okay. Well, that's no bueno either. So we've made a new bug. Maybe. Okay. So offset X and offset Y for one is the width of... there is an error here. This offset here, the phaser range, is a box that the top left corner of this box is going to be like, oh, our ship's not going to be in the middle of it, essentially, is the problem with this. That's the problem. So this needs to be this truncated by the division down by 2. Okay. And this is just begging for some better types and a better API. However, I'm going to make it work first. And then the offset has to be added to that in order to get the actual in-world coordinates of that we want to check that against the enemy's position, essentially. All right, because the ship position X is the ship's position in the quadrant space. But the offset isn't. So top left X, top left Y here in enemy in range is fine. And top left X plus offset X is great. That should be good. All our tests still pass. So we don't have a test that's actually catching this error, which is concerning. No, still not getting it. Let's see. So what we're calculating is the range box corner and giving to enemies in range might be off. Yeah, we'll just debug that here, say. No, let's keep that there. What's our handy dandy function so I can do the pure stuff? Release Haskell. What's that one? What's that one again? Trace show, very handy. Trace M. So we're in like our applicative / monad context, we can just use trace M to do nothing, but just trace out the thing. Which is handy dandy. Okay, empty list. So let's get the range box corner. And we'll show up the range box offset. Ah, okay. Range box corner is calculating as -1, -1. That would be a problem. Which Ship phaser range divided by 2. 6 divided by 2 should be 3. It should be max. No, max isn't right either. It should be something else, I think. At least 0, is somewhat right. That should be 6-6. Yep, 6-6. Okay. The enemy ship is at, that's in sector, it's at 8-3. So 6-6. Yeah, it's out of range in our case. So we'd have to move closer. Let's move it 4, 6, no, move 6, 4. Yeah, okay, let's fire from here. This should hit it. There we go. Okay. And then we go 14, of course. Phasers should do nothing. Okay. There we go. We got it. We need to clean this code up a bit, but we got it. Sweet. Okay, let's go create a commit for this. Alright, fix phaser range bug. Boom. Alright, chat. We're getting close to time here. Let's see if we can do just a quick little... Let's see if we can clean up this a little bit. So what I don't like about this code right here is that we are... When we're handling the fire phasers, we're manually calculating the range around the ship in order to gather all of the enemies that are range of the ship in the sector. So we have to pull all that data out here in order to do that. In order to get the enemies that we're going to be firing on. I feel like we should be able to extract out this code here into its own thing, and that will be much nicer. That'll make this, we can make this more generic, this range function. We could, yeah, do a bunch of stuff with that. So what I want to do here is I'm going to pull this code up, out. I have a function that is going to be basically get enemies in range, in phaser range. This is what I would like to have. And I would like to be able to get rid of this. And just have that. This is the code I would like to have. Get enemies in phaser range. We should actually return the association list of enemies. Let's reformat this. Get rid of this binding, and we can just return it. Value of this expression. Super. Okay, that's good. So the game still works. The refactor was great. Test still passed. Well, we were really testing this. But now we can add tests for that, if we wanted to. So that cleans up that code a little bit. I feel like it was doing a little bit too much. Cool. Let's do that. Stage that. Enemies in phaser range. Okay. Cool. Let's clean up our commits here. Squash that into that. Oh, we gotta remove the say dialogue stuff too. That is extra of that. so that is in simulation, I think. Now, where did we see the duplicate state? Yeah. I'm just going to delete it. We're going to get some complaints from the compiler, probably. Yeah, and it's right there. In simulation. $38. I don't know why it's not working here. Oh, yeah, we don't need... No, I see why we need that version of dialogue still. Yeah. So, if we look at dialogue module, this save dialogue function doesn't operate on the game state itself, whereas this one does. So this one's really like a helper function that we used with the lens stuff. Let's see. We used it in combat, right? We could at least move this over. And we could implement add dialogue in terms of say dialogue. Roommate message. For consistency's sake, do it like that. And we have an import that we need. Well, this might be why we had it in the state modules, because this is probably going to do circular import. It is. That's why it was there. I don't remember. Let's see here. Rebring in the dialogue again. Get it all compiling. Okay. We could even make this better. By making a state function as well. It would be super nice if I went like this. We said we had like just a function like a dialog prime here. Instead of that. That would look like this. Crewmate, text, state, game state. And crewmate message. I think this might be a nicer API. Yeah. Oh, that's much nicer. Yeah, let's get rid of that. So I'll make this like an internally kind of helper-y function. Move it up here. Yes, friends. Yes. I like it. It's much better. Okay, cool. All right, some minor little tidy up there. Okay, let's push that up. So, if this is your first time tuning in, or you're tuning in again, welcome back, hello, and hello new people. All the code that you've seen tonight is in this repo here at Lambda Trek on GitHub. I'm Agent Ultra. It's been a pleasure. You can find me also on the Fediverse as well. I am on the types.pl server here at Agent Ultra, so you can follow me there. What's up, Chexor? Welcome back. It's been a while. We're just tuning out, saying the goodbyes. Yeah, so Lambda Trek is coming along. We're doing well. We've got combat coming along nicely and looking good. And there's the code. So follow me along on the socials. Go to the link above. Get on our Discord channel as well. There are lots of other people that are also on that Discord server who do streaming in not only Haskell, but other cool declarative style and functional programming languages too. So if you're just starting on your journey and you want to find more peeps to hang out with that are kind of on the same level and the same vibe, go there and check it out. You can also, chat and share your questions and your projects and ask any questions you don't want to ask on stream or whatever. And of course, you can, if you're on the Twitches, you can ding the thing and subscribe to get notifications and all that stuff. I'm sure you know how to do that by now. And if you're watching in a different time zone on my YouTube channel, you know what to do there as well. Thanks again for watching. It's been a pleasure. May your monads always be free and your types always check. And we'll see you next week. I usually do these streams on Tuesday evenings at about 10 after 8 in the evening. So that's the Eastern Standard Time Zone, by the way. The name's Agent Ultra. I like you. I will hope to see you next week. Take care.